Hello class, this video will demonstrate a proper assembly of gears in Solidworks, and we're going to use the part we modeled in tutorial number 6. Here's the part we modeled in tutorial number 6. If you recall that we have equation driven parameters, basically the diametric pitch and n. If you change the value set here, and the gear should be automatically updated. Okay? Yeah. I think there's one little thing I wanted to point out here. Let me make a little change based on my previous modeling here. Okay, so that changes is basically for the involute curve that over the involute profile layer, and which is under this sketch here. So let's go to this sketch. Okay, front view here. So click on this involute curve. So in tutorial number 6, I give a 0.68 as a time change or angle change. So maybe it's a little bit too small for some other combinations of a number of t's and diametrical pitch. So let's put it to 1 and here. So same thing for this one here. Let's also change that to 1. Okay, so now it's updated, nothing changes here. Okay, so now for my assembly purpose, I'm going to use diametrical pitch 2, which is 2, and then number of teeth for the pinion, I'm going to use it as a 13. Okay, so as you know that 13 is the minimum number to avoid interference. Okay, click OK. So it looks something wrong here, but in the circular pattern right here, we need to update that from the current 36 to 13. Okay. So that's the gear we're looking at here. So this is the one we're going to use that as the pinion here. So let's save that as a pinion. So we're also going to need a gear, right? We're also going to need a gear. So let's probably save before we let's save as. Okay, let's save as another copy to get a gear. Okay, there we go. So for the gear, same number of diametrical pitch. So let's say number of teeth, that's 26. We have a gear ratio of 2 to 1. So remember to change that circular pattern right here to 26. So that's automatically updated. Everything looks good. Now you can save that. Okay, so let's open that pinion again. Okay, so you can have both parts open. So now we're ready to create the assembly, but let's create a few more things right here before we start assembly here. So let's cut a hole in the middle here. Right? So click on the front plane. Click this here. Let's cut a hole. So dimension that. So really, you can use an equation to drive this hole diameter. Okay, if there's a change on the dimension here, but that's not critical. So let's just leave it as it is. Okay, and create an extruded cut for this circle here. Let's do them all. Okay, there we go. Okay, so I'm going to show you a little trick to properly assemble the gear and the pinion. So in order to do that, okay, we're going to create. Okay, first of all, okay, let's create an axis. Okay, that's the axis, basically rotational axis of this pinion. And then we're going to create a assistant line here for assembly. So here's the line I'm going to create. So let's look at the front view here. So starting from the center, okay, go to the middle here, go to this outer edge of those gear tooth, snap to the middle of that. Okay, snap to the middle here. Okay, so there we go. That's the line here we're going to make use of. So we can change the line into a construction line here. Okay, so those are basically what we need for the pinion. Okay, so we're going to do the same thing for the gear. Okay, so let's cut a hole to the front. Okay, just for cosmetic. big would that be? Maybe 6. Okay, yeah. Okay, so let's cut here. Through them all here. Okay, and then create axis. Check mark. Create a line at here. So from plane. Okay, create a line here. So this time we're gonna use this line, snap that to the middle of this dedenum circle at here, this little portion here. Okay. So same thing, make the line as construction line here. Okay, so that's it. That's all we need. Now we're ready for assembly here. So let's create a new part, new assembly. Okay. So we got everything here. So let's just drag the pinion and the gear into the assembly. Okay, so first of all, okay, so let's make this guy float. Okay. Second of all, okay, we're going to create the mating now. Okay, so and the first mate is to make the two surfaces coincident. Now the next one is let's create the center to center distance here. Okay, so we can make use of the axis that we just created. Okay, for the pinion and the gear. Okay, so we're gonna apply the center to center distance at here. So the first one, this is n equal to 13, p equal to 2, so the pitch diameter is 6.5. Okay, n divided by 2, or n divided by p, and this is 26 divided by 2, so 13. So 13 plus 6.5, okay, and divided by 2, 9.75 is the center to center distance. So let's punch in 9.75 here, center to center distance. Okay, yeah. Okay, so in most of the assembly videos that you probably see is what people normally will teach you is just try to move or orient these two, okay, just by moving it properly here, so something like this, right? So that it looks about right between this pair at here, okay? But that's not very accurate, and this is the purpose why we created these two lines here. So we're gonna try to make this mating, okay, very accurate, since our gear and the pinion are created very accurately. Okay, so this is what we're gonna do. Let's create another mate. Okay, so create a mate here. So click on this origin. Click on this origin in here. Okay. So I'm gonna fix that origin to the origin in here. Okay, but we don't align the axis, so just coincident with the axis here. Okay. Yeah. All right. So then I'm gonna try to first of all I'm gonna try to move this thing here. Okay, move this thing in here. Okay, and basically try to make it a line here. Okay, so let's take a look at the front view here. It's not quite front view here, right? Okay, so maybe I'll create another mating here. Okay? So because of the mating, the constraint of this one here, the front plane is not exactly the front plane of this one. So front plane of this with this guy here. Alright, so that's a perfect front view here. Okay, then I'm gonna approximately move this up, so just for cosmetic thing here. Like that, alright? Yeah, that's alright. Okay, so then now create a mate. So click on these two lines right here. Okay. So click on coincident. Okay, it's almost coincident now, right? So it's okay. Yeah. So check mark. Okay. Check mark. So now, because of these two assistant lines right here, they are. Wait a second here. Yeah, I think there's around here. So redo that. Okay. So clear that. So click this line. Click this line here. There we go. So that's the proper mating here, right? Yeah. You see, the purpose is you probably will see now. Let's temporarily get rid of that. Because right now it's not quite to line here. So I'll just temporarily get rid of that. Then I'm gonna move that to a little bit here. Move that to a little bit here. Okay. Yeah. Okay. So that's all right. Then do the mating here. So get rid of that surface. Choose this line. Choose that line. There we go. So that looks better. Okay. So this is the proper mating head here. As you can see, okay, this is how the gear are supposed to be assembled. Okay. Now, unfortunately, we are not going to use this constraint, so we have to suppress this constraint. Otherwise, the gear won't move. Okay, so let's suppress that constraint in here. So more important is, right, we want a 2-to-1 ratio of motion in here. So that next constraint is we're going to make use of Solidworks mechanical constraint in here. In Solidworks, that is a mechanical mate. Okay, so what you do is, right, you click on the axis that we created. Okay, so select this axis, and also select the axis for the gear. Okay. Then under the mechanical mate, choose gear. The ratio, that's going to be 1-to-2. So 1 here, 2 at here. So check mark. Okay, and check mark. So now you have this mechanical constraint. So the motion of this will have this 1-to-2 ratio at here, right? Okay. So as a matter of fact, if you move that, you can see, right, there's already motion in here. Okay, so it's pretty good. Okay, so just to demonstrate that, so let's create a little simple motion study here. Okay, I'm gonna create the motor, apply that to this surface right here. So change that RPM to maybe very slow one, maybe to 5 RPM for better look. Okay, and now click on calculate the motion study. Okay. So he calculated by default about 5 seconds here. Right? Yeah. So now if you replay that, there we go. That's a perfect gear motion between pinion and gear. Okay. Excellent. So if you've got any questions, let me know. Right? Thanks.